Okay, mga kaka, this is the last topic na pinakahihintay natin lahat. So again, yung topic, last two topics, hindi na siya kasama sa final exam ninyo, but isasama naman natin sa assignment ninyo. So magbibigay ako ng last assignment. Now, so overall, you have 10 assignments. Again, itong last two topics, hindi nakasama sa final exam ninyo. Okay. So, for the last topic, topic 15, is what we call the total differentiation. So, yung topic 14 is just the part or partial derivative. So, pag pinagsama natin yung partial, ito na yung total differentiation. Actually, ito yung dinidiscuss natin mula nung simula pa lang. Yung process ng derivative natin, yung pagdi-derive, one dependent, one independent, dy over dx. So, yung solid na d, yung hindi malanding d, yun yung total derivative. So, medyo iibahin lang natin ng konti lang yung approach. Yung independent variable, diba kung natatandaan ninyo, dy over dx. Tapos yung normal natin na dy over dx. Okay, for example, mayroon tayo ditong 2x. So, yung dx, nililipat lang natin sa kabila. Dy is equals to 2x dx. So, parang ganun lang yung gagawin ngayon natin. But again, to solve for the total derivative, we need to solve also the partial derivative. So, pagsasama-samahin natin to, yung partial, to make it the whole totality. Okay, so, total derivative, if c is equals to the function of two independent variable, which is continuous, with continuous function of two variables, now x and y. That has a continuous partial derivative of yung partial z with respect sa x and partial c with respect to y. Para makuha natin yung kabuuan ng derivative, so we're going to add yung partial z with respect to partial x times the total derivative of x, plus the partial derivative of c with respect sa y times the total derivative of y. Yun yung pinakakabuuan ng dependent variable z, no, dc. Kaya pag siya, for example, naging 3 independent variables na rin siya. Let's say, a is equals to, tapos may b, may c, may d. So, parang pahabain lang natin yun, no? For example, what is the total derivative of a, where, let's say, function, if a is equal to the function of b, c, and d. So, parang tatlo yung independent variable natin. So, getting the total derivative of the function a. Okay, so yung partial derivative ng, of course, yung a over partial derivative of b times the total derivative of b plus partial derivative of a, kasi yun yung hinahanap natin, divided by the partial derivative of c times the total derivative of c. And last, the partial derivative of a with respect to d times the total derivative of t. So, yun yung pinaka-pattern natin. Now, kahit maging 4 pa yan, 5, hanggang dumami yung independent variable natin, pwede pa rin natin i-derive or to get for the total derivative. So, yun lang yung gagawin natin. Partial derivative times the total derivative with respect kung ano yung diniderive natin. Okay, so, paano ngayon natin yan nakuha? So, kailangan mo i-memorize yan. Actually, we can prove it, no, by using the two independent variables. So, balik lang tayo sa pinaka-basic no? Tapos it follows na yan kahit maging 3 independent variable na yan, 4, and so on and so forth. So let's start with the two variables. So based on the function or the definition, if c is equal to the function of two independent variable x and y, so we have x and y. So if we're going to get that derivative na yung normal na ginagawa natin at first, total derivative of c, so we can get with respect sa x. So ibig sabihin, lahat ng walang kinalaman kay x magiging dapat constant. Pero since we have two independent variable, hindi magiging constant si y sa total derivative. So we're going to apply product rule. So we have x times the derivative of y with respect sa x, kasi yan yung kinukuha ngayon natin with respect sa x, plus may product rule y times the derivative of x with respect sa x. So wag ninyo munang i-equate sa 1, ha? Okay, kasi iba yung magiging process natin. Since all the denominator is dx, so we can multiply the whole equations by dx. So ano yung matitira? So matatanggal lahat ng common kasi equation siya. So we're going to have dc is equals to x dy plus y dx. Okay. So same thing, if we're going to derive the original equation where z is equals to xy, but this time with respect sa y, so product rule pa rin tayo. Now, so we have x times the derivative of y with respect sa y plus y times the derivative of x with respect sa y. So again, hindi natin i-equate yan sa 1 kasi may kukunin tayong ibang form where all the denominator is dy, so we can multiply dy. So mangyayari, we have dz is equals to x dy plus y dx. So in either of the two method, same ang ibibigay na sagot. Where the total derivative of c is equals to x dy plus y dx. So ang tanong, paano naging ganito ang general equation? Okay, so going back to the partial derivative. So ano ba yung partial derivative? So balik tayo ulit sa original equation na z is equals to xy. If we're going to get the partial derivative, no? Okay, by partial derivative, so dito, ito yung rule ng partial derivative para ma-prove natin yung pinaka parang formula, no, ng total derivative. By partial derivative, we're going to get the derivative partially of c with respect sa x. Okay, so partial derivative siya, no? So ibig sabihin, lahat ng walang kinalaman kay x magiging constant. Therefore, we have x times y. So si y magiging constant kasi wala siyang kinalaman kay x times the derivative partial of x with respect sa x. So this is equated to 1. So it means that the partial derivative of c with respect sa x is just equals to y. Okay, and if we're going to get the partial derivative of c, this time naman with respect sa y, so dito ulit ang tingin, ha? So we have x times y. So lahat ng walang kinalaman kay y magiging constant. So ibig sabihin sa x ay magiging constant. Tapos i-derive natin partially si y with respect sa y. So this is also equated to 1. Therefore, that the partial derivative of c with respect sa y is just equals to x. So ano gagawin ngayon natin dyan? Okay, by either of the equation, itong pinaka ginawa natin na dalawa, equal lang naman yan. Okay, we're going to substitute for the value of x and y. So based on the formula that my x, unahin na natin to, that my x is equals to partial derivative of c over partial derivative of y, and where y is equals to the partial derivative of c with respect sa x. Substituting that in the total derivative of c, so we have x, where x, dito tingin, where x is equals to partial derivative of c with respect sa y times the total derivative of y, plus y dx, where y is partial derivative of c with respect sa x times dx. So ito na yung naging pinaka formula natin for the total derivative. Okay, so nagkapalit lang doon ha, but equal sila. So kahit maging tatlo pang independent variable, it doesn't matter kasi ganyan din ang kalalabasan. Yung partial times the total. Okay, plus partial times the total. Okay, so let's proceed for the example. Okay, so example number 1. Find the total derivative of c. So, ang hinahanap ay si dc ha. Total. Hindi malanding d. Equals x cubed y plus x squared y squared plus xy cubed. Okay, so hanapin daw natin yung total derivative. Okay, required is the total derivative. No? So, si dc. So, if this is our equation, solution muna tayo. It equals to x cubed y plus x squared y squared plus xy cubed. Now, if we're going to recall yung formula, di ba? May formula tayo that the dc is equals to the partial derivative times the total plus partial times the total. Okay, natatandaan nyo yun? Okay, so sige, sulat ko ulit ha. That, okay, recalling the formula for two variables and solving for the total derivative is equals to the partial derivative with respect, okay, so since xy lang naman ang independent variable, let's start with x times its total derivative plus the partial derivative of c with respect sa y times its total derivative. Okay, so ganun yung gagawin ngayon natin. So, ano yung mga kailangan? Find this one. Okay, but yung dx and dy, since wala naman sa given siya, so, ang nawawala lang natin ngayon ay itong dalawa. So, kasi minsan sa given, yung total derivative ay meron na value. So, yung dx and dy will remain as is. So, ang nawawala yung partial derivatives. So, hindi kayo makakapag-total ng walang partial, ha? So, let's start getting the partial derivative of c. Tingin dito. With respect, unahin natin sa x. So, since it is partial derivative, lahat ng walang kinalaman kay x magiging constant. So, at the first part or first term, x cubed y. So, with respect sa x, si y magiging constant. So, parang nilabas mo lang si y. Kasi constant siya times partial derivative of x cubed. So, ano ba yung partial derivative ni x cubed? Okay, so we have 3x squared. Partial derivative of x, which is the base, over partial derivative of x. So, parang sinabi natin 1 lang. Okay, plus, so yung y squared constant, okay, medyo shortcutin ko na, derivative of x squared, yung parang normal lang is 2x. So, hindi ko na pinakita, ito yung partial x over partial x. Plus, okay, y cubed is constant, and derivative of x is just equals to 1. Therefore, kung maayusin natin, 3x squared y plus 2xy squared plus y cubed. So, this is the first part. No? Yun yung unang part na nawawala. So, if we're going to get this time, partial derivative of c with respect na sa y. So, dito ulit ang tingin. So, wala walang kinalaman kay y, magiging constant. Therefore, yung first term na x cubed y, constant c, x cubed. Ang derivative ni y with respect sa y is 1. Good. Plus, okay, si x squared, constant, times derivative of y squared is 2y. And plus, x is constant, and derivative of y cubed is 3y squared. So, rearranging it, everything, x cubed plus 2x squared y plus 3xy squared. So, ito naman yung sa second part ng partial derivative. So, pwede na natin kunin si total derivative, or the total derivative is equals to the partial derivative of c with respect sa x. It is equals to 3x squared y plus 2xy squared plus y cubed times, okay, yung total derivative ni x. Okay, plus partial derivative ng c with respect sa y is x cubed plus 2x squared y plus 3xy squared times the total derivative dy. Okay, so yan lang. Ganyan lang kadali ang total derivative. No? Pero may application to. So, doon rin tayo mag-focus. Okay, so ang question naman, paano kung time rates ang pinag-uusapan? Okay, yung time rates na ibig sabihin, yung total derivative ni z, itong total derivative ni z, paano kung with respect sa time? So, ano mangyayari? So, ganun lang rin. I-derive nyo yung total derivative magiging dc with respect sa time over dt. Tapos, yung dx, for example, with respect sa time. No? So, magiging with respect sa time, with respect sa time, with respect sa time. Okay, so, yung ganun ang mangyayari. So, yun yung continuation nito. Okay. So, ito yung magiging parang formula niya. So, getting the total derivative of c. Hindi na yan hindi na siya yung malanding d. With respect sa dt, so parang total derivative siya, is equals to the product of the partial derivative of c with respect sa x times the total derivative of x with respect sa dt. Plus, kasi 2 variable siya, 2 independent variable, so partial derivative ng c with respect sa partial derivative ng y, yung second independent variable, times, again, the total derivative of y with respect sa total derivative of t. So, if the case that you have two independent variable, so, i-imagine nyo naman kung magkakataon na tatlo yung magiging unknown variable mo. Let's say, let's see, equals, okay, halimbawa, a function of let's say, w, x, and y. Yan, tatlo naman. So, parang dadagdagan lang din natin, no, yung pinaka-formula, the total derivative of c with respect sa t. Naglolo ko lang yung pen. Equals by partial derivative ng c for the partial with respect sa partial derivative ng first variable times Okay, yung total derivative ng W with respect sa total derivative. Okay, so susundan nyo lang yung pattern na yan. Partial derivative ng C with respect sa X naman times its total derivative. Okay, and last, partial derivative still ng C with respect sa Y times the total derivative of Y. So, ganun yung magiging pattern niya, no? So, hindi naman kailangan i-memorize. Okay, so ang tanong, paano nakuha itong pinaka-equation na yan? Okay, so, ito na tayo. Okay, to make it more or well explained, so if I have Z, okay, gamitin lang natin yung two variables para hindi nakakalito. Okay, is equals to xy. So, dalawa yung independent variable ngayon natin. So, sabi dito, if I have two variables, if I'm going to get the derivative of C with total derivative of C directly, okay, palabasin kasi natin yung pinaka-equation niya. So, with respect sa t, it means product rule ang gagawin natin. Kasi with respect sa t, hindi naman with respect sa x, or hindi rin siya with respect sa y. So, product rule, x times the total derivative of y with respect sa t. Plus, y times the total derivative of x with respect sa t. Okay, so nasusundan. Now, ano ang magiging value ngayon ni x at saka ni y? So, that's the next question. So, if I'm going to get, okay, rewriting again the equation, the partial derivative of the two independent variable, x and y. So, partial derivative of c, unahin natin muna kay x. Kaya, partial derivative of c with respect kay x. So, partial tayo ha. Magiging constant yung isa. So, magiging constant ngayon natin si y. Kaya, y times derivative of x is 1. So, yun ang mangyayari. And also, if I'm going to get, writing again, c equals xy, the partial derivative of c with respect sa y, so we have partial c over partial y is equals, okay, ang magiging constant naman ay si x. Kaya x, copy x, times the derivative of y, partially is 1. So, ito na yung magiging value ni x at saka ni y. So, substitute ngayon natin dito. Ayan. So, writing again the total derivative of c, total derivative of c. So, we have x, where x is the partial derivative of c with respect to y, times the total derivative of y with respect to t. Plus, okay, yung y naman is partial derivative of c with respect sa x times the total derivative of x with respect sa t. So, same answer din ang mangyayari. Okay, so, nagets na yung total derivative din natin is actually just the whole or yung kabuuan ng mga partial derivative. So, to make it more clear, we're going to have an example. So, sagot lang natin isa ha. So, moving on the example. Oops, sorry. Okay, if c is equals to x squared, y, x is equals to t squared, and y is equals to 2t. Find the total derivative or dc over dt. So if you still can recall that problem, actually chain rule yan. O, sa chain rule natin makukuha yan. Kasi nga, si c ay equals kay x squared y. Ang hinahanap naman is the derivative of c with respect sa t. So, walang t kay x, walang t kay y. No? No, sa main equation, let's say this is equation 1. Pero, hindi pa pwede maging constant si x kasi si x ay equal kay t squared. Tapos, hindi rin pa pwede maging constant si y kasi nga si y ay equal kay 2t. Okay. Kung ganyan yung problem, syempre, mas madali if we're going to apply direct substitution. No, para isolve agad natin si dc over dt. So, paano mangyayari? Direct substitution natin. So, c equals okay, x squared. So, si x, palitan agad natin ng t. So, t squared na naka-squared. Tapos, si y, palitan na natin agad diretso ng 2t. Okay, so simplify muna natin na mas maayos. So, magiging t to the 4 times 2t or simply equals to okay, 2t to the 5th. So, that is your c. Tapos, pwede na natin i-derive diretso. Getting the derivative of c with respect sa dt kasi yun yung hinahanap. So, we have dc over dt is equals to, okay, power rule lang naman yan. No? Bring down 5 times 2. We have 10t to the 4th. So, ganyan kadali actually yan. No? Pero, pag in case na yung problem ay may mga square root na yan, so, syempre, mahirap i-evaluate yan ng nung substitution ng directly. Kaya, ina-apply natin yung chain rule. Kung saan medyo mahaba lang siya, pero madaling i-derive kasi pinaghiwalay-hiwalay na yun natin. Now, pwede ba natin gamitin dyan yung partial derivative para masolve natin yung total derivative? So, yun yung ina-explain natin before. So, recalling again the formula, di ba? We have C. Okay, ano yung formula na yun? Okay, dc, over dt is equals to partial derivative ng c over partial derivative ng x. Ito yung formula kanina, no? Hindi ko na ulit i-derive, no? Kasi yun yung pinaka-formula na sabi ko madali namang i-memorize. Times its total derivative. Okay, plus, i-derive na natin kanina, partial derivative ng c with respect sa partial derivative ng y times the total derivative of y. Okay, ayan yung pinaka-formula ngayon natin. Okay, kung ito yung pinaka-formula ngayon natin, we need to look for the components. Yan. Yung 4 na terms na yan. O function na yan. Okay, so isa-isahin ngayon natin. So, to solve for partial derivative ng c with respect sa x, okay, dito tayo pupunta sa main equation. C is equals to x squared y. Okay. Getting the derivative partially of c with respect kay x. So, partial c over partial x is equals, okay, constant si y ha. Kaya ang derivative ni x squared ay 2x times y. So, meron na tayong partial derivative ni c with respect sa x. Okay, so paano naman natin kukunin si dx over dt? So, si dx over dt, kukunin ngayon natin, of course, kay x is equals to t squared. So, we have x. Ito muna gawin natin. X is equals to t squared. So, getting the derivative, total tayo, with respect sa t. So we have dx over dt is equals to, okay, derivative ng t squared is 2t. Okay na rin. So, meron tayong first and second function. Okay, now, for the second part, okay, partial derivative ng c with respect sa partial derivative ng y. So, kukunin ulit natin yan sa main equation or yung equation 1 na c is equals to x squared y. Okay, so same procedure. Getting the derivative of c partially, but this time with y. So, we have partial derivative of c with respect to y is equals to, okay, pag sinabing equals to, lang, ay, medyo nagulo, no? Intindihan pa naman. Okay? So, constant ngayon, si x. Kaya si x squared will remain x squared. Derivative ni y ay 1. So, medyo nagkalkulo na dito. We have this is x. Is t squared to. Okay. So, okay na tayo. Okay, so kung kukunin ko naman sa total derivative ni y with respect kay t, kukunin ko yan dito sa y is equals to 2t. Y is equals to 2t. So, getting the derivative, total naman to with respect na sa t. We have dy over dt is equals to 2. Okay, so, babalikan ko na tong equation na to. So, meron na akong partial derivative ng c with respect sa x. Ito yun, si 2xy times dx over dt. Ito yun, dx over dt which is 2t. Okay, plus partial derivative ng c with respect sa y. Ito yun, which is x squared times dy over dt, yung kasasolve lang kanina, times 2. So, we have 2 times 2, 4xyt plus 2x squared. So, it's just yung dc over dt. Yan yung sinasolve natin, no? Okay, so, equals. So, substitute the value of x. Ano yung value ni x? 2t squared. Oh, sorry. X is just t squared. So, we have t squared times y. Ano value ni y? 2t times t. Plus 2. Again, what is x? X is t squared na naka-squared pa sa labas. So, 4 times 2 is 8. T squared times t is t to the 4th. Plus 2. T squared raised to 2 is t to the 4th. So, similar terms, just add the numerical coefficient. We have 10 t to the 4th. So, this is now my total derivative ng c with respect sa t. Okay, which is the same answer. Okay, so mahaba lang yung sa chain rule, pero ang gusto ko lang ipaliwanag dito that you're going to have the same answer if you're going to apply partial derivative. So, kung sa application yan, for example, yung area ng rectangle, no? Area is equals to length times width times the height. So, 3 independent variable yun, no? Length, width, and height. So, yung ginagawa kasi natin dati doon, pag dinerive natin sa area, yung length, width, and height na 3 independent variable hanggat maaari ginagawa natin isa. Na puro length na lang lahat, or puro width, or puro height. Naghahanap tayo ng equations. So, pwede natin gawin, we can solve the derivative of area or total derivative of area by getting the partial derivative. No, unahin mo muna with respect kay length, tapos with respect kay width, tapos with respect kay height, tapos i-apply nyo yung total derivative, itong general formula. So, ganun din ang kalalabasan nun. Medyo mahaba lang siya, pero mas maikli. Okay, so that's it for our session sa partial derivative. So, yung process niya, hindi nagbago. Okay, para lang maintindihan ninyo. Kasi gagamitin natin yan sa differential equation. So, I hope you understand our topic and also have enjoyed. So, don't forget to subscribe, like, and hit the bell, no? Para sa tuwing may ipopost ako, na-update kayo na merong bago. Okay, so medyo mamimix lang yung video natin sa YouTube channel ko na may pang first year, may pang second year. So, lalagyan ko ng category on kung differential equation or for differential calculus. Okay, so God bless us all and always be safe. Okay, bye-bye. Let's proceed to the application examples of the total derivative. So, kasama pa rin ang partial dito, ha? So, let's solve the problem. The altitude of a right circular cone, so pag sinabing right circular cone, in right triangle siya, okay, is 15 mm or millimeter. No? Yung altitude, that's the real height. No? Kasi may slant height pa tayo eh. So, pag sinabing altitude, yan yung perpendicular. Yung talagang height na patayo, hindi patagilid. Okay, is increasing at 0.2 millimeter per seconds. So, mayroong original height na siya ng 15 mm, tapos lumalaki pa siya ng 0.2 mm kada isang segundo. Okay, so mamaya mas visualize natin yung pag may drawing. Okay, so may effect rin naman, no? Habang lumalaki yung height or altitude ni right circular cone, yung radius naman ay, ano nangyayari? No? Originally from 10 mm, nagdi-decrease naman ng 0.3 mm. So, syempre, para siyang tumatangkad pero pumapayat. So, how fast is the volume changing? So, ano na pa, apansin nyo, imagine niyo meron kang triangle cone, parang ice cream, no? Na yung height, ganito lang, tapos biglang tumangkad, pero yung pinakataba naman niya, na medyo mataba, biglang pumayat. So, ano mangyayari sa volume? Mas lalo bang dumami yung laman? Or mas kumonte? So, alam nyo na ibig sabihin, no? Time rates kasi to. Pagka positive ang sagot, ibig sabihin, maraming laman, dumami. Pero pag nag-negative ang sagot, hindi ibig sabihin na yung volume na hindi na nga zero, wala na, may utang pa kasi negative. So, pwedeng lumabas na negative sign, it only tells us that decreasing yung volume. Kasi wala naman sinabi rito na decreasing, pero sinabi lang how fast is the volume changing. So, pag positive, lumalaki. Pag negative yung sagot, ibig sabihin nag-change pa rin siya, but in a negative way or lumiliit siya. Okay, so ito yung figure. If this is our right circular cone na merong height na 15 mm, tapos meron ding radius na 10 mm, okay, ang nangyayari, yung 15 mm mas tumataas. So, habang tumatangkad si 15 mm, si radius naman nagiging maliit. Okay, so ayan ang magiging itsura niya ngayon na bago, no? Tumangkad, pero lumiit. So, originally 15, yung height, tumangkad na, hindi na natin alam, Pero yung pagtangkad niya, ang bilis ay 0.22 mm. Okay, so 0.22 mm. Okay, tapos yung pagpayat naman niya ay 0.3. So parang mas mabilis pumayat, no, kaysa sa tumangkad. Okay, so ang tanong, how fast is the volume changing? So it means volume with respect sa time. So required is dV over dt. Okay, so with respect sa time siya. So total derivative with respect sa time. Kaya kung i-imagine ninyo, para ka lang rin nagdi-derive dati na yung unang nating topic hanggang after pa ng midterm exam. Pero ito pwedeng solve yan using yung normal na ginagawa natin before. Pero mas minsan, no, mas effective at mas madali ito gamitin using the partial derivative. May mga problem lang minsan na hindi rin advisable pag ginamitan ng partial derivative kasi mas mahaba yung magiging solution. So, tanong muna, ano ba ang formula ng volume? Kasi volume pinag-uusapan. So, let's write. Volume is equals to base area. So, capital letter B. So, ano ba yung area or shape ng base circle? So, ibig sabihin, base area is area ng circle. Okay, so may 1/3 pala yan. 1/3 volume. Kasi 1/3 base area times the height. Okay, so we have 1/3. Yung base area is a circle. So it means we have 5r squared times, of course, the height. So, if we're going to focus on the formula of volume, so ilan ngayon ang independent variable? Okay, dalawa. Isang radius at isang height o letter H. So, kung susolve natin yan before, nung muna nating discussion, di ba? Dapat lahat, hanggat maaari, isang independent lang at isang dependent. So, sa independent, mamili tayo dyan. No? Either lahat gagawing R, ibig sabihin si H papalitan ng R. O kaya lahat ay H, si R papalitan ng H. No? So, pero hindi ganun ang gagawin natin. We're going to apply the total derivative. So, ibig sabihin, total derivative ng kabuuan. So, pag kukunin lang natin, no? For example, hindi siya with respect sa time. Parang kinuha lang natin yung dV. Recall lang tayo ulit sa topic kanina lang. Is equals to, okay, partial derivative of volume. Kasi nahanap natin, no? With respect, okay, dalawa independent variable. Let's say R, radius times the total derivative of R. Okay, plus a partial derivative of volume with respect sa isa namang independent variable na H times its total derivative. So, kailan papasok dyan yung time? So, we can multiply both sides by 1 over dt or divide by dt everything. So, dv over dt. So, ayun na yung time rate. Is equals to partial derivative of volume with respect sa radius times dr total derivative of radius with respect na sa time. So, ganun lang yung mangyayari. Okay, madali namang intindihin. Okay, so ito na yung magiging general formula ngayon natin. So, ano-ano yung mga kulang? So, based doon sa given. Yung given kasi, ano yung given? Yung sulat. Okay, dapat given pala na una, no? Merong 0.2 mm per second. So, time rates yan. Okay, kanino ba nakarelate yung 0.2 mm or millimeter per seconds? Diba sa altitude of a right circular cone. Yun yung point 2, yun yung bilis. So, ang representation kasi natin for the height, ginawa na natin h eh. H na siya. Palitan lang natin yung kulay. That's H. Tapos, ito naman, radius. Okay, kaya kung yan ay H, yung 0.2 mm, siya yung DH over dt. Ganyan daw kabilis na tumaas yung height. Tapos, yung 0.3 naman, mm, pertaining kay radius, kaya siya ay rate of change ng radius sa time. Okay? So, balik tayo ulit. Meron na tayo rito dr over dt. Check na yan. dh over dt. Check na yan. So, ano na lang nawawala? Partial derivative ni volume with respect sa time as a radius at partial derivative ni volume with respect sa height. Okay, so paano ngayon natin kukunin yan? Okay, so isip. Balikan natin yung formula ng volume, where V is equals to 1/3 pi r squared. That's H. So, nawawala ay partial derivative ng volume with respect sa radius. So, yun ang unahin natin. So, getting the derivative of volume with respect sa radius partially. So, partial derivative of volume with respect sa radius is equals to, okay, yung 1/3 pi, constant na siya. Lalabas na natin. So, sino pa? Okay, si H. Kasi with respect sa radius yan. Kaya, ang i-multiply na lang natin or ang kunin lang nating derivative ay si R. So, we have 2R. Okay, so nakakasunod. Constant si H siya kasi with respect sa radius. So, partial derivative of volume with respect sa radius. So, we have 2/3. Inuna ko lang yung 2 pi HR. Okay, so meron na tayong partial derivative ng volume with respect sa radius. Okay, so paano ngayon ang magiging value ni H at saka ni R? Okay, so that's the time na i-apply na natin. Okay, yung value ni H at saka ni R. So, partial derivative of volume with respect sa radius is equals to 2/3 pi times H. Okay, ang H natin is 15 and our R is 10. So, ano yung magiging partial derivative ni volume with respect kay radius? 100 pi for dV over dr. 100 pi ha. Okay. Tapos okay, this time with respect naman kay H. Okay, so ganun pa rin. We have 1/3 pi constant with respect sa H kasama na si R squared as constant pa rin. So, dito tingin. Tapos si H with respect sa H is 1. Okay, so we have 1/3 pi. Radius is 10 squared. So, 10 squared is 100. So, we have 100 pi over 3. Now, for partial derivative ni V with respect sa H. Okay, so now, we can solve for the total derivative of volume with respect sa time or rate of change ng volume with respect sa time. Okay, by the way, yung 10 mm natin, obviously, no, ito kasi yung size niya kanina, kasi nakalagay dito eh. Okay, the volume or the radius of the base is decreasing. Okay, meron naman dyan. So, decreasing, symbol for decreasing, it must be negative. Negative dapat to. Okay, kaya yung given, negative dapat lalagyan. So, hindi pa pwedeng hindi lagyan ng negative. Okay, kasi pag hindi nilagyan ng negative, yung magiging final answer, positive. So, magiging mali siya. Okay, bakit magiging mali? Kasi yung volume ay paliit. Kaya hindi pa pwedeng sabihin, sir, okay na yan, nakalimutan ko lang yung sign. So, hindi pa pwede yun. Ha? So, yung 0.3 na yan ay negative. So, mamaya papalitan natin yan. So, dV is equals to partial derivative of volume with respect sa R, which is 100 pi. Sorry. Dito natingin, ha? Dito natingin. And, so, we have 100 pi times dr over dt. So, ano yung dr over dt natin? And dr over dt is negative 0.3. Ayan. So, importante yung negative doon. Okay. Plus, partial derivative ng volume with respect sa height. We have 100 pi over 3 times dH over dt. So, given is 0.2. Okay, so try natin computin, including the pi, para makuha natin yung total derivative ng volume with respect sa time. So, let's try computing it. We have negative. Okay, sinama na natin yung value ni pi. 73.303. So, 3 decimal numbers na walang rounding off. So, unit. Okay, volume kasi yan. So, mm or millimeter cube with respect or with with respect to so pwede naman with respect. Okay, millimeter cube per seconds. So, ganun daw kabilis lumiit yung change. Okay, sa book ninyo, yung pi hindi na isama yung value, no? So, may pi na value doon. But still, the answer is negative 73.303. Kung hindi nyo ginawang negative si 0.3, so may iiba yung magiging sagot. So, kaya doon pala sa problem, you have to analyze kung lumalaki ba siya or lumiliit. So, that's the application problem 1. For the next problem, ito approximate ito. No? So, pwedeng sa tansya or pag-a-approximate pwedeng gamitin din yung total derivative. So, this is a good example. So, find the approximate value of the cube root of 28. So, hindi lang sa cube root pwedeng i-apply ito, ha. Pwedeng sa square root, sa fourth root. So, ito yung magiging pinaka-pattern niya. So, ang gagawin natin muna, since it is just an approximity, okay, so sulat natin yung problem. We're going to represent the problem cube root of 28 be y. So, y is equals to cube root of 28. So, ito yung nawawala. Lagyan ko ng question mark. So, if, let's say, gawin muna natin x yung value sa loob. Therefore, y is equals to the cube root of x. So, ito yung pinaka magiging problem natin, no? which is x raised to 1/3 in terms of exponential. So if you have two variables, one dependent and independent, so kung natatandaan ninyo yung formula, getting the total derivative of y is equals to a partial derivative of y with respect doon sa independent variable times its total derivative. Pag single, independent, yan lang. Pag double, plus, diba? So, ito yung parang magiging general formula natin. No? Pero hindi dyan tayo magre-rely mamaya sa pag-solve natin ng y is equals to cube root of 28. Okay, so let's continue. So, in this formula, kailangan natin makuha yung mga sumusunod. No? Yung una, yung partial derivative ni y with respect sa x. Kailangan din natin kunin si dx para makuha natin si dy. Tapos si dy, kukunin natin mamaya yan para masolve natin si y. Okay, ano ibig sabihin doon? Yung dy kasi, no, total derivative. Again, derivative means difference. So, parang delta y, kung natatandaan nyo, di ba? Delta y, in-apply ng limits, kaya naging derivative. So, difference pa rin niya, kaya nga d. Difference ng ano yan? Yung dy ay difference ng yung pinaka-malaking value minus its initial value. So, ano naman tong initial value? Yung initial value kasi, yan yung pinaka-approximate na value na kukunin natin, pero hindi yan yung pinaka-hinahanap, no? Yun yung medyo malapit na number sa final answer. Okay, kaya nga approximity ang ibig sabihin. So, dyan natin mamaya kukunin yung value talaga ni y, no? Based on sa problem. Okay, where y is equals to, okay, so dy plus the initial or proximity value. Okay, so yun yun, no? Yung y is equals to cube root of 28. Okay, so hanapin muna natin si partial derivative of y. So going back again to the equation where y is equals to x raised to 1/3. So if I'm going to get the partial derivative of y with respect sa x, parang normal derivative lang siya, bring down 1/3, x, tapos si 1/3 minus 1, we have negative 2/3. Or, this is the same as 1/3, tapos x raised to 2/3. So, para mas madaling intindihin, gawin muna natin siya pansamantala radical. Okay, pwedeng nasa loob yung 2, pwede rin nasa labas yung 2, no, according sa rule ng exponent. Kasi mamaya gagamitin natin yan. Okay, so meron na tayong partial derivative of x squared. So, substituting partial derivative to dy, okay, so we have 1/3 cube root of x quantity squared dx. Okay, so yun yung magiging value ngayon natin. So, ano yung gagamitin nating value ni x? Siyempre, hindi 28 kasi yun nga yung pinaka-problem doon, no? So, dito, yung x na to, gawin muna natin siyang initial. Mag-a-assume tayo ng value ni x na malapit sa 28 na may perfect cube. So, gawin natin, let x, okay, where na lang, where x sub I is the near perfect Kasi walang calculator kunwaring gamitan, no? The near perfect cube number 228. So, yung x sub I daw, siya daw yung number na perfect cube na malapit sa 28. So, ano ba yung number na may perfect cube na malapit sa 28? Okay, siya si 27. So, if we're going to continue to solve for the value of dy, so we have 1 over 3. So, kaya natin ginawang radical para mabilis ma-compute, no? Cube root of x sub I, where x sub I is the perfect cube number 27 na naka-squared, times dx. Okay, so yan pa isang problema. Ano ba yung dx? So, again, dx is the difference of the two values of y. So, dalawa na yung magiging value natin ng y, no? So, parang x minus x sub I. So, kasi ganyan din yung hinahanap natin mamaya kay y na dito. Ayan ang gagamitin natin mamaya. Ayan. So, dito siya galing. Okay, so ano value ngayon ni x? Yung original value ni x, which is 28, minus yung initial value ni x sub I na perfect cube number na malapit sa 28 is 27. Okay, so try nyo rin to sa square root, cube root, mag-invento kayo mamaya after this. So, dx is equals to 1. Okay, so now we can solve for dy. So, dy is equals to 1 over 3. Okay, yung cube root of 27 is what? Diba, yung cube root of 27, yung 27 kasi is 3 raised to 3. Kung walang calculator, times dx is 1. So, cancel na to. Kung gusto nyo magpasikat, walang calculator, yan. Ito yung ginagamitan din pala ng pagkuha ng mga root na yan, no? Using calculus. Pero may ibang may ibang method yan, yung hahanapin nyo rin yung close value. Pero medyo mahaba-haba yan. Yung hindi ka gagamit ng calculus. So, yung 3 raised to 2 magiging 1 over 3 times 2 times 3 raised to 2. So, 3 raised to 2 is 9 times 3 is 27. So, yung dy is equals to 1 over 27. So, meron na tayong value ni dy. So, going back to the equation that dy is equals to y minus initial. So, ang hinahanap natin ay si y. So, dy plus y prime or y sub I, which is the initial, ito yung hinahanap natin si y. Kasi ang hinahanap is cube root of 28. So, what is our dy? Okay, na-solve na natin. 1 over 27 plus, okay, si y sub I, initial value ni y sub I, okay, yung y kasi is cube root of x, diba? Cube root of x. Since this is initial, yung x rin na sa loob ay initial, which is y. So, babaliktarin ko lang ha, y is equals to 1 over 27 plus cube root of x sub I. Yung initial value natin is 27. And the perfect root of 27 is 3. So, we have 1 over 27 plus 3. Okay, so yan na yung pinaka-final answer. Kung check nyo sa calculator yan, okay, the value of 1 over 27 plus 3 is equals to 3 in decimal number, no? 3.3 decimal number, 0.37. So, that is the same as cube root of 28. Check yan. Okay? So, sa approximity, pwede rin isolve yung total derivative. Okay? So, for your last assignment, okay, so yung pinaka-last part na yun ng book ninyo, So, sa wakas, natapos din. Pero, kung yung book ninyo ay may hyperbolic and inverse hyperbolic, hindi na natin i-discuss yan, ha? So, yun yung pinaka-list kasi na importante. Kaya hindi na natin sinama kasi ang differential calculus dati is 5 units na naging 3 units. So, hindi talaga natin kayang matackle lahat. But, I am happy and at the same time proud kasi natapos talaga natin yung course content natin at sobrahan pa dahil sa partial derivative and as well as the total derivative. For your last assignment, okay, merong 10 problems, actually, tama, no? 15 problems pala sa pinaka-last exercise on your book. So, doon sa application, no, yung application, kasi yung part 1, 1 to 5, yung part 2 is 1 to 10. Yung part 2 yung may application eh. So, doon sa part 1 na 1 to 5, mamili lang kayo ng 3. So, hindi siya worded problems. Tapos, yung sa part 2 naman na 1 to 10, yung starting with 4, number 4, 5, 6, 7, 8, 9, 10, worded problem yon. Mamili kayo ng 2. So, for your last assignment, 3 hindi application ng total derivative at 2 worded problems ng total derivative. So, that's it. And I hope mag-aral mabuti, lahat may chance pumasa. No, kung ayaw pumasa, huwag mag-aral. Joke. So, God bless. No, aral mabuti ha. Huwag magpababanjing-banjing kasi sayang yung oras. Okay, so God bless us all and thank you very much.